The majority of agricultural nitrous oxide emissions derive from the process of denitrification. This process occurs when patches in a soil become anaerobic during flooding or compaction. Certain soil microorganisms can sustain themselves in such anaerobic patches on the energy released during the stripping of oxygen from nitrogen compounds, nitrate to nitrite to nitric oxide to nitrous oxide to dinitrogen gas. Transfers between the steps of this pathway are leaky, and leaks from the second to last reaction step release substantial amounts of nitrous oxide to the atmosphere. Indeed, the agricultural practice of heavy fertilization and irrigation at the beginning of the growing season to establish a crop generates a burst of nitrous oxide. Management practices that diminish nitrous oxide emissions from agricultural soils include A. More even distribution of fertilizer and water, and B. Improved field drainage through accumulation of soil carbon and avoidance of soil compaction. Combustion of fossil fuels by farm machinery is the second largest source of greenhouse gases from the agricultural sector. Minimum tillage refers to management practices that leave large pieces of plant residues in a field and reduce turnover of topsoil layers. With minimum tillage, farmers eliminate one or two field operations and combine other operations into a single pass of a tractor. This diminishes soil compaction and soil erosion and conserves 20% of total fuel use. Humans consume more rice than any other cereal, and rice is grown on more than 150 million hectares worldwide. Most of this rice is wetland rice. Cultivation of wetland rice involves planting into shallow standing water and raising the water level as the crop grows. This eliminates competition from most weeds, as well as ensures an adequate amount of water for this water-demanding crop. Rice fields or paddies are allowed to dry as the crop matures. In a process known as methanogenesis, soil microorganisms under anaerobic flooded conditions harvest the energy released during the breakdown of organic carbon compounds into methane. This process emits as much as 700 kilograms carbon equivalents per hectare, or 1.5% of the world's greenhouse gas emissions from human activities. Mitigation options for rice production are few. Water management practices, which drain paddies during the middle of the growing season instead of keeping them under water continuously, diminish methane emissions by 15% to 59%, but depend on the availability of additional water to reflood the paddies and add from 5% to 9% to production costs. Rice cultivars may differ in their root exudations of organic carbon and thus in their support for methanogenesis, but evidence that these differences influence methane under field conditions is inconclusive. Agricultural burning serves several purposes. First, it quickly clears land of plant residues, a task that would otherwise require a large investment in labor, equipment, fuel, and time. Second, it returns some of the mineral nutrients and the biomass back to the soil. Finally, burning produces high temperatures that sterilize the topsoil layers to reduce pest problems for subsequent crops. The downside of agricultural burning is that most of the organic nutrients in the biomass literally go up in smoke rather than enrich the soil. This burning dissipates all the nitrogen, some of it as nitrous oxide, and all of the organic carbon, either as carbon dioxide, carbon monoxide, or methane, depending on oxygen availability. Together, these greenhouse gas emissions amount to roughly 12% of the world's total from human activities. Lastly, burning reduces the albedo of the land surface, the amount of sunlight reflected, for several weeks and enhances the amount of solar radiation absorbed by about 5%. Alternatives to agricultural burning include A. Physically removing plant residues and using them for feed, bedding, or biofuels. B. Chopping residues and mechanically incorporating them into soils. C. Controlling pests through crop rotations, time of planting, and chemicals. And D. Leaving fields fallow and letting natural decomposition occur. Usually farmers employ a mix of these alternatives. Domestic animals kept in pens produce prodigious piles of poop that become anaerobic and release methane and nitrous oxide. This source amounts to 1% of the world's greenhouse gas emissions from human activities. Composting, which regularly turns over manure and other organic material to promote aeration and the faster decomposition of aerobic respiration, diminishes the emissions of methane and other putrid products from aerobic respiration. Alternatively, farmers cover the manure and other organic materials to induce anaerobic conditions and capture the methane thus generated for a fuel. In Europe, during 2006, such operations produced biogas equivalent to 1.3 million metric tons of oil, or about 0.5% of European oil production, excluding Russia.